Welcome to this explainer. Today, we're taking a really deep dive into the architecture of building production-ready Go client libraries. We're using an excellent guide on building a Go client library for the Catcha AI API as our anchor today, but honestly, the lessons we're going over apply universally. If you've ever built or maintained backend systems, you already know that keeping integrations clean is a constant battle. It's usually a battle fought at 2 a.m. on a Friday while everything is on fire. So we're going to transform this topic from a story of architectural chaos into a solid blueprint for complete operational order.
Let's kick things off with a bit of a ghost story. You know how it goes. A backend team usually starts with a super simple integration. One service needs to call an external API. So, a developer writes a small function. It submits a request, waits for a result, handles a response, and returns a value. The code works perfectly, the feature ships, and the team just moves on. But what happens next is where the trouble always begins.
Because the integration spreads like wildfire. By month 2, another service needs that exact same API. A background worker copies a chunk of the logic, then a QA tool adds its own flavor. Next thing you know, a batch process is using completely different timeout settings. One service is retrying errors that should definitely not be retried, while another just keeps polling long after the parent request has been canceled. Eventually, you hit month 6, and nobody's entirely sure which implementation is actually correct. Your infrastructure is just a tangled mess.
Now, that is the exact moment a client library stops being just a simple developer convenience and becomes a full-blown operations layer. A Go client library for an external API is not just a wrapper around HTTP calls. Once multiple services depend on it, it actually defines how your entire organization handles timeouts, cancellations, retries, fatal errors, polling behavior, proxy routing, balance checks, and integration consistency. So this forces a pretty massive shift in our mindset. The question is no longer just, can the team call the API? The much better and honestly much more critical question you need to ask is, can the team operate this API dependency predictably across services? If the answer is no, you are sitting on a ticking time bomb of technical debt.
All right, let's get into Section 1, the production checklist. Here are the 8 steps to order. Step 1, define the operational role. You've got to ask yourself, is this client used by a quick throwaway script or a critical customer-facing system? Maybe it's a QA pipeline or a major production workflow. The more important the workflow, the tighter your reliability requirements need to be. Then step 2, centralize that logic. Stop duplicating API calls across services. You absolutely must put your submission, polling, balance checks, typed errors, and timeout behavior into one single client library to prevent wild, unpredictable behavior. Step 3 is absolutely crucial. Use context cancellation. Look, in Go, context. Context isn't just a nice convention. It is vital. It helps parent requests, Go routines, workers, and HTTP handlers cancel long-running work cleanly. If the parent workflow stops, the API operation should stop immediately too. That prevents the absolute nightmare of orphaned polling loops, wasted resources, and phantom background work that nobody owns. Step 4, classify your errors clearly, because let's face it, not every error should be treated the same way. Some are completely fatal, like invalid keys, IP restrictions, or an error zero balance. You just need to stop immediately. On the flip side, some errors are just temporary hiccups, like transient network issues or not ready responses. A production-ready client has to explicitly separate those fatal roadblocks from temporary failures. That is what helps teams dodge retry storms and diagnose incidents so much faster. Building right on that control, we have steps 5 and 6. Step 5, make timeouts and polling configurable. Different workflows have completely different limits. A background job might tolerate a nice long wait, but a user-facing workflow needs a rapid timeout. Defaults are useful, for sure, but real production systems demand control. And step 6 goes hand in hand with this, allow custom HTTP clients. Production environments require custom transport behavior, things like proxies, tracing, security settings, or specific network routing. A good Go client should support custom HTTP client injection instead of hiding all that transport behavior away. Step 7 is all about observability hooks. A client that only returns a token or a generic error is basically useless when things break. You need to expose the whole story to get a good production signal. Task ID, method, duration, error code, timeout status, and result status. Teams desperately need this visibility into request volume, success rates, and workflow attribution to actually understand what the library is doing out there in the wild. And finally, step 8, assign ownership and versioning. A shared client library needs a champion. Who actually updates the error mappings? Who defines the default timeouts? Who owns the version releases?
And who makes sure downstream services upgrade safely? Without clear ownership, the client library just becomes shared infrastructure without a clear operator. Moving right along to Section 2, Common Mistakes to Avoid. Let's rattle through what amateur integrations usually look like. Mistake 1, they let every service write its own API logic, creating a chaotic web of dependencies. Mistake 2, they use lazy, generic error strings instead of Go's robust typed errors. Mistake 3, they just let polling loops run wild long after cancellation, eating up server memory. And mistake 4, they hardcode timeout and polling values, which completely robs downstream services of the flexibility they actually need. Moving from messy code to some serious operational risks. Mistake 5 is hiding your HTTP transport configuration. Mistake 6 is skipping balance checks or production metrics entirely. And mistake 7, which is incredibly critical for integrations like CapTcha, is building automated capture workflows without reviewing platform rules, privacy requirements, contractual terms, and operational risk. These types of automated workflows absolutely must only be deployed in owned, client-authorized, or contractually permitted environments. All right, let's jump into Section 3, Real-World Troubleshooting.
Let's map some common symptoms to immediate cures, using the CAPTCHA AI Go integration as our guide. CA context deadline exceeded. The symptom is your solve just took too long. The cure is simple: bump up your client's timeout setting. Hit an arrow zero balance. The symptom is you're out of funds, so the cure is to go top up at the dashboard. And if your polls just never seem to complete, stop staring at the logic and check your network connectivity or verify your API URL constants.
We can apply that exact same symptom cure logic right to the code setup itself. Symptom, you're getting a compiler error on errors.as. Cure, you're just missing an import. Add errors to your import block. Symptom, your custom HTTP client isn't actually being used. Cure, it's almost guaranteed someone forgot the with HTTP client option. Just make sure you pass that option when initializing the new client. Now, let's tackle a really quick FAQ from the source material that sums up a lot of our architectural philosophy today. Why use context instead of just a simple timeout? Well, because context connects cancellation across the wider Go system. If the parent request, a worker, or a Go routine is canceled, the API operation stops immediately. This ensures you never have orphaned polling loops secretly consuming valuable API credits in the background. We've covered a massive journey today, transforming chaotic, duplicated API calls into a structured, observable, and strictly typed Go client library. But I want to leave you with this final provocative thought. Without ownership, the client library becomes shared infrastructure without a clear operator. So take a really hard look at your code base today and ask yourself, who really owns your infrastructure? Thanks for joining me on this explainer, and keep building brilliant systems.